I'm going to teach you how to read a number in any given base. This one here is in base 10, this one's in binary, and these two are in hexadecimal. These three are the same number in three different bases. So this one is the smallest, which means it has the highest base. Alright? A base is just a fancy way of saying kind of like how the number is represented. So we write numbers in base 10, which means the first column of digits, let's say we've got 100, the first column of digits is this one, the second is this one, and the third is this one. The first column has a value of 1, the next one has a value of 10, and the next one has a value of 100. They go up by 10. Sorry, they don't go up by 10, they times by 10. So 1 times 10 is 10, 10 times 10 is 100. This keeps going and you get to 1,000, 10,000, 100,000, etc. And it never stops, it just keeps going. Because it's base 10, it timeses by 10 each time. And that is from the right to the left, not from the left to the right. So this number here, it's 1 times 100. It's 100, obviously. This one is different. What's the value of this one? It's 1 times 7 plus 3 times 10. And then I'll just write that down here. Plus 1 times 100. And that ends up being, if you don't even need to put that on your calculator, please don't do that. It's 137. Hopefully you got that answer. If you put that in your calculator, please don't do that. That's because this is in base 10. We can just look at a number and read it because it's in base 10. And the reason for that, the reason we count in base 10 is because we have 10 fingers. I know that might be obvious, but you know, just in case. This is base 2. And you'll notice that if I just go through this, you've got, give me 1 second. No, it's a bit messy, but you got 1, 2, 4, 8, 16. And this just keeps going, you know, you get 32, that's so messy. You get 64, you get 128, and it just keeps going. And you might be able to tell already, it's timesing by 2 each time, right? Because it's base 2. Okay? This one's base 10. I would love to change color, but no. So this is base 2. It goes up by timesing by 2, right? In each digit column. And you'll also notice that in base 2, there are only 2 different types of digits, 0 and 1. In base 10, how many different types of digits are there? There are 10. What a coincidence. 0 to 9. That is no coincidence, actually. And if you go up to base 3, which is called ternary, then you'll actually have 0, 1, and 2, which is 3 different types of digits. Let me just clear this. Okay, here's a nice different color for your eyes. So, I'm going to go through some more things. Basically, think of numbers as a list of digits, which you might already do that, right? So 731 is not actually 731. They've been lying to you. It's actually the digit 7, and then the digit 3, and then the digit 1. And in base 10, you can only have 10 different ones of these, right? You can only have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And they are all of the digits you can have. In base 9, you can only have up to 9 different digits. You can have 0, 1, 2, 3, 4, 5, 6, 7, 8. And, okay, so what happens when you go above 10? And you have, say, base, let's say 12, base 12. Alright, what do you think will happen? You got 0. I'm just going to count up. 0, 1, 2, 3, 4. Everything looks normal so far, and I forgot to even write 12. There we go. 5, 6. Continuing up here, 7, 8, 9. What do you think will happen next? It can't be 10 because we're not moving up a column yet. So it's A. That was messy. It's A, and then it's B. Do you see what's happened there? We're using the alphabet now. Now, you don't have to use the alphabet. You could use any symbol that exists, ever. But we just commonly use the alphabet because that's just what we do. So then comes 10. Alright, so you're counting up. This is still 7. It has a value of 7 in our base, which is base 10. This is still 8, that's still 9, but that is 10. In base 12, if you convert an A into base 10, that's 10. This is 11, and this is 12. Now, have a look just for a second, right? The digits 1 and 0 are really good because they actually tell you something about the base of the number, right? So if you tell me that this number is in base 16, then it must be 16 in base 10. I know that might be confusing, but just bear with me, okay? So that's the same as saying this, but this is in base 16 and this is in base 10. Do you see what's happening there? Yeah. 10 in base 12 is 12 in base 10. But don't get used to that because that is not how it is for other numbers. That is just a trick, okay? Just a little thing you can visualize. So give me a moment. I'm just going to clear the screen again. Alright, I hope this helped a bit. I'm just going to try and summarize the stuff that I've talked about. So with all the different bases, right, you can only have a certain number of different digits, and that certain number is the base number. So in base 10, you can only have 10 different digits. In base 2, you can only have 2. In base 16, you can only have 16. In base 36, you can only have 36. But in bases like 36, you end up having to use the entire alphabet. You end up with, 0, 1, 2, all the way up to 9. And then you go A, B, C, all the way up to Z, and then you get to 10. And 10 is the special number, remember, because it tells you what base the number's in. So 10 is 36, remember, because this is in base 36, this is in base 10. This is the number 35 because it's the last digit. So in base 10, the last digit is 9 before the 10. And so that's the highest digit. In here, Z is the highest digit, and it happens to be the number before the base. Hopefully this makes sense, and I'm not just saying a bunch of words, but I might come back to this at some point later. Just as a quick final thing, I'm going to go over how to read numbers in any base again, because I know, reading numbers in any base is kind of hard, and that's alright. So I'm just going to give a number. I'm just going to write a bunch of digits. 267. But it's not in base 10, it's in base 8, because I said so. And so this is in base 8. You'll want to remember back at the start, I talked about how these have different values, and it starts at 1 always, and then it goes up timesing by the base. And so you've got 1, 8, 64. I know that's messy, but just, it's fine. And you get 7 times 1 plus 6 times 8. And then you, whoops, my pen's being funny. Plus 2 times 64. And so, oh gosh, my pen. Okay, and so you basically just put that in, that's it. 7 plus 48 plus 128. And so you end up with 183 in base 10. And you don't have to write 10 because that's implied. And that's it. This, by the way, base 8 is called octal, spelled O-C-T-A-L. Yeah, that's it. Might do, there's examples in that binary video I made a while ago, if you want to have a look at binary examples. This one here is an octal example in this little box here. Yeah, that's it. If you want more examples, then just comment, please. I'd be happy to do more examples. I would also be happy to do examples converting from base 10 to other bases, like the reverse of this, so like grabbing this number, turning it into this. Anyway, yeah. Goodbye.